Okay.
So
What would you like to talk? Which one's the third one?
So this one is only adding on this one bit at the end.
Okay. Let's see if we can come up with the equation that this represents.
So this is showing that n squared equals n minus 1 squared, this is this bit here, plus 2n minus 1. Or I suppose it could be 2n minus 1 plus 1, so you have these 2 and this bit here.
Okay, nice. And why did you, you're right, so there's two n minus 1s plus 1, or you also wrote it as two n's minus 1. How would you represent that?
So, well, there's this section here and there's this section here, but they have this overlap, so you have to subtract it away.
Okay, nice. That's really great reasoning. And is this true, by the way, algebraically, that n squared equals n minus 1 squared plus 2n minus 1?
Well, we do it out. N squared minus 2n plus 1. You see that these would cancel each other.
Okay, cool. All right, so now let's look at the last one here. This is kind of a fun one, this last one.
In this one, you're dividing it this way. 3, 4, 5, 2, and then 1.
Okay, so what is this showing?
Let's see, so this could also, let's see, so it's n squared. And then you have 2 times 1 plus 2 plus 3 plus all the way up to n minus 1. So this goes up to 4, and then plus n, which is the section of 5.
Okay, neat. So n squared, so this is an interesting formula. N squared equals twice 1 plus 2 plus 3 up to n minus 1 plus n.
Yep. So I think this sum here would equal, well, sum 1 plus 2 plus 3 up to n would be n times n minus 1 over 2.
Okay.
So this would be n minus 1 times n minus 2 over 2. If we did it for this sum.
Just this part inside the parentheses.
So times 2 would just be this, and then we get n squared minus 3n plus 2 here plus n, so n squared minus 2n plus 2.
So something must have gone wrong. Let's see if we can think a little bit more.
So,
Because it should equal n squared. And so we definitely have the plus n at the end, so you did that. So something must have been wrong with your original formula. So that you said that 1 plus 2 plus 3 up to n minus 1, you said that was n minus 1 times n minus 2 over 2.
and up to n it would be n times n minus 1 over 2. Was it? I think it might have been n times n plus 1 over 2.
Okay, well let's check. Let's check it for n equals 1. So if I just have 1.
So, oh yeah.
If my formula is n times n minus 1
If it would
over
work,
2.
it would be 0.
Okay, so what is the formula?
N times n plus 1 over 2.
Okay. Now let's just double check. 1 plus 2.
Over 2, it's 1.
So this should be 2 times 3 over 2. Okay. Alright, so now you have a formula. So,
and times n plus 1. So this would be n minus 1 times n over 2 times 2. So you'd get n squared minus n plus n.
okay.
Cancel it.
That's nice. So that's from a formula. Can you see any other way that we could look at this side and see that it equals n squared? It comes from the picture, but can you see what from the algebra what's happening here without the sum formula for the inside?
Well, you have two almost halves of the square, and just this little strip is left over. So you could write it as 2 times 1 plus 2 plus 3 all the way up to n, and then minus n if you double counted this.
Okay, yeah, that's cool. Let me show you one other thing that's going on. Those are all nice ways to look at it. We could write this as, I could take one of these and say it's 1 plus 2 plus 3 plus up to n.
Yeah.
And then I could do this thing where I write this backwards. So I have an n minus 1 down to a 1. So I could have an n minus 1 plus n minus 2 plus n minus 3. And I would stop at n. I would stop at 1, and that would correspond matching the n minus 1. And then I would
So you
get
n times.
Yeah. So that's how that works. Okay. Good job, hon. That was really nice. That's very neat. How all these different ways just to see what n squared is. That was cool. Good job.